Okay, and the recording has started. Any questions before we start?
What about the guest lecturer? Is that fixed yet?
No, not yet. I'm waiting for a confirmation from them. They were supposed to respond by the end of November, but I haven't received a response yet. So I will have to. I have already pinged them back, so I'm waiting for an answer now. Because they have already given their word, so I will try to make sure that they keep their word.
Great, looking forward to it.
All right. Besides that, I have already made the announcement concerning the makeup exam in place of the midterm. So if you want to participate and you have a valid reason for it, please let me know via email so that we can make the proper arrangements. Those who have already contacted me about it do not need to contact me again. Okay, anything else? Yes, you will be having a homework this week concerning probably concerning the patterns that we saw after your midterm. Yeah, that's pretty much it. Anything else you want to say before we start? Okay, so this week class we will be talking about the proxy design pattern, one of the important design patterns, which is all about controlling access to a certain class. It can appear deployed in front of us in a very large number of different contexts, ranging from security to the virtual replacement of other objects and so on. We will look at the examples later on. Suffice familiar with. Now, the proxy design pattern belongs to the category of structural design patterns, along with the decorator, adapter, and of course, composite. Now, the idea is that it will be controlling access. So, what about our example? Now, in this particular case, we once again continue with the example of the gumball machine. And given that we had done a wonderful job in the previous scenario using the state design pattern, now that the CEO is very satisfied with our work, he's of course asking for more. I mean, there is a saying of that type: the only thing that good work brings is more work. Now, the CEO says, hey team, I'd really like to get some better monitoring for my gumball machines. Can you find a way to get me a report of inventory and machine state? Now, this appears as something very simple. I mean, all he wants is just a report of inventory and machine state. I mean, what could go wrong? Now, we could have, very simply, a get count method in order to get the number of gumballs in the machine. And of course, a get state in order to access the current state of the machine. And that's it. We are done. So we would just simply print them on screen and that's it. It will be all over. For instance, given that the gumball machine class contains several variables, including the location where it is located, and of course its location and the number of gumballs are given at its constructor, we could very simply have the proper getter functions in order to access those variables. And a gumball monitor class could receive a gumball machine, which it is supposed to be monitoring. And when we call the report method of the gumball monitor, it would simply print the location, count, and state variables. I mean, this is as simple as it gets. I mean, you cannot go wrong with this. However, and of course, once we test it, we see that there isn't anything extraordinary. However, the CEO is making a correction and says that the monitor output looks great, but he says, I guess I wasn't clear. He needs the monitor gumball machines to monitor the gumball machines remotely. So we need a piece of code that will be executing on a different machine than the machine, the system where the Gumball machine code is running. In fact, he says they already have the networks in place for monitoring, and we are supposed to now provide them with a piece of software that will be able to retrieve the state, the location, and the count of gumballs from machines that are located geographically far, far away from us. So we need to access them remotely. Now, this is of course not a rare requirement. And one of these guys here who are thinking about this problem, they say that we should be using a remote proxy. He says that the problem is that the monitor runs in the same Java virtual machine as the Gumball machine, and the CEO wants to sit at his desk and remotely monitor the machines. So he says, what if we left our Gumball monitor class as it is, but handed it a proxy to a remote object? So basically he says we already have a Gumball monitor class, and that Gumball monitor class is expecting, as we saw earlier, right here, the Gumball monitor class is expecting a Gumball machine reference so that it will monitor it. However, this reference is supposed to point to an object that is present on the same Java virtual machine as the Gumball monitor object. And the recommendation, the suggestion that is coming from this guy here, from Frank, the one on the right, is that we should use a proxy to a remote object. So in other words, we should keep our Gumball monitor class as it is, but instead of giving it the reference to a Gumball machine object present on the same Java virtual machine, instead, we will give it a placeholder proxy object, which the Gumball monitor object will be able to use in order to access the remote object. And the beauty of it will be that the Gumball monitor class will not even be aware of this. It will continue acting, running, as if it has been given a Gumball machine object that is present on the same GVM. So the question is, how can you have an object on a remote machine that is represented, that has a representative, a proxy on a different machine, where other objects can interact with that proxy, and by interact I mean call its methods, access its fields, and so on, as if they were interacting with the original object that is geographically far, far away from us. That's the whole idea in this case. However, you always make this mistake. Every semester, the proxy design pattern is not about only keeping a proxy object representing a far, far away distinct object. And by far away, I mean on a geographically distinct machine. It is much more general than that. The proxy design pattern is about having a representative, a proxy object that controls access to another object. That other object can be on the same machine, can be on a different machine. It's not about geographical distance. Geographical distance is only the example that we have in this present chapter. The proxy design pattern is much more general than that. It is about controlling the access. It might be in terms of security. It might be in terms of efficiency, and so on. We will get to those examples towards the end of the chapter. Now, before we go any further, I would like to ask you, if you were the engineers developing such a system, how would you solve the problem of having objects on one machine that can act as if They are the objects on a far, far away machine. How would you enable the interaction between two objects on this machine where one of them is representing an object at another machine? I mean, what happens when object A invokes a method of object B where B represents an object on a far, far away machine? How would you approach that? How would you implement that if you were doing it from scratch? No frameworks, no libraries, no nothing. Just the general guidelines.
So when we talk about different machines, the sockets ring a bell, as far as I'm concerned.
Yes. So how would you benefit from sockets?
I would establish the connection using a socket and then pass an object from the original machine to the remote machine.
So you would send the entire object from machine 1 to machine 2.
Initially, yeah.
Okay. Do you really need to send the entire object?
Probably not.
Yes, probably not. I mean, what are the kinds of interactions that are possible? I mean, what can this person on machine 1, what can this person do with that object that is on a distant machine, on machine 2? That person can invoke its methods and or access its public fields, basically, or it can do only whatever you tell them that they can do.
We could think of it as a server-client model, actually, having the client send
Okay.
requests and then process the whole thing on the server without having to send the whole object to the client.
So what would you send to the others? But I mean, what would be the type of communication? What would you be transferring from one machine to the other?
It could
Let's
be
keep
like
it simple. Let's say that on machine 1, we simply just want to invoke a method that belongs to an object on a distant machine.
I would
So what would you
resemble a command, maybe. I would send a value that is processed on the other side, that if you get this kind of value, invoke this certain method.
I would send a reference. I don't know how, but a reference it can be easy.
A reference of what?
Object of another machine.
But the reference is just an address. What is the other machine supposed to do with that address? How do you know the address of the object on the distant machine?
I don't know, but sending whole object is not good solution, I think.
No class. I mean, it is a solution, but sending just the object would not be sufficient, because let's think about it that way. We have machine 1, machine 2. On machine 1, we have an object that tries to interact with another object that is representing, that is the proxy for an object that is on machine 2. Now, I want to execute one of the methods of this object that is on another machine. So what do? I have this proxy, and I tell him I want to execute your method, I don't know, your hello method, or print hello world, or whatever. Now, if I try to bring to this machine the entire object from the distant machine in order to execute its method, that will not be even sufficient, because how do you know that that object is not interacting with other objects in order to calculate the result of that method? So maybe that object, through its method, is going to call other methods belonging to other objects. So that means just in order to get the result of that method, you need to transfer not only one object from the distant machine to the current machine, but maybe 10 objects or 20 or 30. You don't know that. And plus, it might result to a very large amount of traffic. It is a better idea to simply send the command. It is a better idea to simply send what you want to be done with the remote object. What you want to do with that remote object. So for example, I want to execute method print hello world of object B. So I will need to transfer that information, the name of the method, which parameters. I mean, maybe it takes parameters too, so I have to provide them too, so that it will be a valid call. Here is the name of the method. Here is the name of the object or class. Here are the parameters. I send them all the way to the distant machine. On the distant machine, it is executed because I have given it all that it needs, the name of the method, the parameters. It calculates the output of the method, and it will have to send me back, if there is, an output, a result for that calculation. Or maybe if it is void, it will send me nothing. So in order to be able to invoke methods remotely, you need to transfer to the remote site the name of the method that you want to invoke, of course, assuming that we have already agreed on the object that we are talking about, the name of the method, the parameters, and then wait for the return of that method. I mean, that's the general idea. Of course, in order to transfer anything between two machines, as Mr. Alpes mentioned, of course, you will need a socket. Now, if we were doing this from scratch, for example, in C, that's what we would need. We would need somebody, some struct, some function, something to collect the request for which method, which parameters, and so on from the local side, from here, from this machine, open up a connection, open up a socket to the remote machine. Somebody on the remote machine, of course, will have to be waiting for that connection, accept that connection, read through that connection, through that socket, which object, which method, which parameters are concerned, use those given pieces of data in order to actually run that method, collect its output, and send the output through the same socket from the remote machine to the local machine. That is a lot of work. That is not a simple feat. That's quite a challenge to have this working across any two. Even though this stuff was very difficult 30 years ago, when I was still a high school student, thanks to Java and .NET and the technology of remote method invocation, nowadays it is very simple, fortunately for you. So thanks to the RMI, remote method invocation, or RPC, remote procedure call, those are the two different names in the two different worlds, Java and Microsoft, RPCs and RMIs, but they're basically doing the same thing. We are able to invoke the methods of objects on remote machines. That's the whole idea. And that is an example, just an example, where the proxy design pattern takes place. But remember, the proxy design pattern is much more than that. It is much more general than just remote method invocation. Now, unfortunately for us, this book is a bit outdated, even though it has a very high pedagogical value. So here it is explaining the concept of Java RMI using a bit of an older technology. Do not be overwhelmed, do not be scared, but by what you will see, because it appears a bit complicated, because luckily it has been simplified quite a lot nowadays. So now let's look at the details. If you have any questions at all, feel free to ask whenever you want to. Now, to remember the problem, here we have the CEO's desktop, so the local memory, local heap, and then we have the remote heap. Now, on the left, we have the Gumball monitor class, which wants to interact with the Gumball machine, which, however, is located on the remote heap. So it cannot access it directly, because we are talking about two different address spaces. Plus, it is a distant and geographically distinct machine. So the idea that we're going to implement is that we are going to have a proxy class which represents the Gumball machine, and the Gumball monitor will interact with the proxy, and only with the proxy. It will interact with the proxy as if the proxy is the Gumball machine. So the proxy will have the same methods available to the public as the Gumball machine has. And the beauty of it will be that the Gumball monitor will be acting the same. It will not perform differently depending on whether it is a proxy or the actual object. The gumball monitor will be unaware of whether it is talking to the actual gumball machine or to a proxy of the gumball machine. And why is this beautiful? It is beautiful, it is pretty, it's nice, because it will reduce maintenance cost. Because it means that the gumball monitor will be written once, it will be coded once, and we will use it as much as we want to. It will mean that we will be able to modify the proxy and put an actual object or put a different proxy, do whatever we want to without ever having to modify the gumball monitor. Okay. Your client object acts like it's making remote method calls, but what's really doing is calling methods on a heap local proxy object that handles all the low-level details of network communication. So all the socket opening, object transfer, not object transferring, sorry, method parameter transferring, collection of method invocation results, transferring them back, and so on, we will not be dealing with that. Luckily, it will be the Java virtual machine that will be taking care of that. Now, this code is going to be, of course, tricky to write, but fortunately for us, we have the RMI to help us. Now, this is the question that we talked about just a few minutes earlier. This is an interesting question. Should making remote calls be totally transparent? Is that a good idea? What might be a problem with that approach? What do you think about this? By transparent, I mean that the object that is making the method invocation has no idea whether it is invoking a method on a remote object or a local object. It is completely transparent. So do you think that this is a good idea to make them 100% transparent?
Well, there are costs or consequences in doing remote invocation.
What kind of consequences?
Like delays, for example. Let's say something happened on the way and a part of the information was lost. Now, if our initial model does not know that this might have come from a remote destination, it might treat it or error handle it in a way that because it thinks it's actually existing local gumball machine. So the error handling might be not compatible with the way the proxy works.
I see. Okay.
Or maybe
does anyone have? Yes.
Mm-hmm.
Does anyone have anything else to add? What do you think about it from the point of view of security? Application security. Objects that are executing methods on other objects without knowing whether they represent remote objects or not. Do you think security-wise that it could represent a weakness?
Could you be more specific?
You have an object A that is calling a method on object B, but it has no idea whether object B is an object on this machine or whether it is just a placeholder for an object at somebody else's machine.
Meaning if the third party accesses the the proxy.
I mean, does it open up risks?
Interception might be a problem. I'm not sure.
Yes, it could be a problem. Well, there is no clear answer to this question, but the first thing that comes to my mind in terms of a problem is that security-wise, you need to be really, really careful with this. And you definitely need a secure socket for this. This is not something that you would implement using regular sockets. You need you definitely need encrypted communication for this. So not normal sockets, but secure sockets. Anyway, that's out of the scope of this curriculum. It was just a question of general knowledge, but I agree with your opinions. Now, let's get to our example. Now, here we have agreed that we should be using the RMI technology from Java or RPC from the .NET world in order to solve this situation, but we are not here in order to learn about RMI. We are not here to learn about RPC. We are not here to learn about Java frameworks or anything. That's why we don't care whether it is old or new. What we are interested in is seeing how the design pattern takes place in this whole thing. Now, those of you who are interested in the RMI perspective can explore the details, check the current implementations from the latest version of Java in your own time, because our priority will be the object-oriented analysis and design perspective. Now, before we get into the details of the Gumball machine, we will talk about how RMI works in the case of Java as a simple detour. So this is not our priority. This is just for general knowledge. Now here, basically the idea is that the client represents the side that invokes the method, the side that wants to execute the remote method, and the server represents the machine where the actual object that contains that method actually takes place. So the client object wants to access the service object. And since it cannot do it directly, it is using a helper on the client side and of course a helper on the service side. Now the helper on the client side is basically the proxy object. So it is the object that takes place, is a placeholder for the service object, and the client object interacts with it as if it was the real deal. The service helper, on the other hand, it is responsible for getting the request from the client helper, unpacking it, and actually calling the method on the real service. That is his job. Whereas the client helper pretends to be the service, but it's just a proxy for the real thing. So the client object invokes the method, do the big thing. The client helper transfers that request to the service helper. So actually opens up a secure socket, where this method is, which object might contain it, because imagine a scenario where you have multiple objects on the JVM available for remote method invocation. So the service helper is responsible for determining which exactly object are you interested in, and then which method of that object, and then providing the corresponding parameters. So you need a registry of some type. Bir kayıt defterine ihtiyaç var arkadaşlar. A registry that will contain which objects are available for remote method invocation and which methods of these objects are available for remote method invocation. So that's why you will need a kayıt defteri, a registry, in order to store that information. And it is the duty of the service helper to study, to examine, to go through, sift through that registry in order to figure out where that object is on the JVM containing the method that this remote client is interested in executing. After executing it, well, it will simply take the result and send it back packaged up to the client helper through a secure connection, and the client helper will present it. The client helper will present it to the client object. Now that's a lot of work. That's a lot of work, and especially considering that all of this has to happen as efficiently as possible. Java RMI. What is the terminology? Well, in the old times, and by old times I mean 20 years ago, the stub represents the client helper. So we don't say client helper, we say RMI stub. And the RMI skeleton represents the service helper. In the newer versions of Java, including the ones that we have today, they don't require an explicit skeleton object. But somehow they require something on the server side that will still be behaving similarly to a skeleton. So in the old days, you needed to create 2 additional classes in order to handle this stuff, whereas nowadays, just a stub is sufficient. Now, let's look at the old version first. Step 1, a remote interface First, to declare a remote interface. This is the interface that defines, the remote methods that you want clients to call. So this is the interface that is defined on the that the client, that contains the methods that the client can call remotely. It's what the client will use as a class type for your service. Okay, so both the stub and the actual service must implement this. So this is the interface representing the methods that are available remotely. Maybe you contain 100 methods, but only 2 of them are available for remote invocation. So those are the methods that will take place in this interface. And of course, this interface has to be implemented. So the methods that are available for remote invocation, well, you need to actually fill in those functions, those methods, and that is the remote implementation. Step 3, generating stubs and skeletons. Now, fortunately, the stubs and skeletons were produced in the old times automatically. You don't have to even create those classes or look at the source code that generates them. It is all handled automatically when you run the RMIC tool that comes with your GDK. So it is a very simple command that you can use in order to produce automatically the stub and skeleton. Now, if you think about it, you don't really need to do anything. I mean, it's pretty much determined in this case. So it will, no matter what the application, it will have to open up a socket, receive the the object, the method, the parameters, make the invocation, return the result. So that is the same thing for all projects, for all objects. So there is no need to have something that is project specific. That's why they can be generated automatically. Step 4, as you can see, there are a lot of steps. Step 4, starting the RMI registry. So the RMI registry, this is the command that will be that will be executing on the service side, on the server side. And the RMI registry is, as it says here, it is like the white pages of a phone book. It's where the client goes to get the proxy, the client stub helper object. And of course, you will have registry. That's a lot of stuff. So this is the remote service. This is the part that will be expecting basically the connection. That's a lot of stuff. There is a stub, there is a skeleton, there is a registry, there is a remote service, and you need to execute everything in the correct order in order to make it work. Now, let's take a quick glance before we look at the actual current situation. I'm trying to scare you in the meantime. So step 1, making the remote interface. So public interface my remote extends remote. So this is an interface extending another interface. It has to do this. All the methods must be declared as throwing a remote exception. Okay, because there are a lot of things that can go wrong here. As Mr. Alp has emphasized, I mean, there can be communication problems and so on. So we need a different type of an exception in order to cover, in order to span those things that can go wrong during this fragile communication. Be sure that arguments and return values are primitives or serializable. Why not objects that are not serializable? Well, because we will not be able to send them to another machine. Either they have to be primitives or serializable so that we will be able to pass them through a socket. That's what serializable allows us to do. So for example, public string, say hello, throws remote exception. So this is a nice candidate, a good candidate for a remote invocation. Step 2, here we have the implementation of the say hello method. So public class my remote implementation extends unicast remote object, implements my remote, and here is the remote method. Okay, so this is the code that will be running on the server side. It is necessary that it extends the unicast remote object. So that means we cannot use a class that has already extended something else. You also need a no argument constructor that declares a remote exception. My God, that's too many things. And then additionally, you need to register the service with the RMI registry. So basically, now that you've got the code representing the remote method, you need to make it available to remote clients. And how do you do that? You do it by instantiating it and putting it into the RMI registry, which must be running or this line of code fails. So RMI registry is a piece of code, is an application that is running separately. We saw the code before, the command in order to execute it. So once you have created the service object on the server side, you have to bind it with a certain name. You have to bind it with a certain name. Why? So that this service will have a name on your system. So whoever looks for a certain method in this object, they will be looking for it by using the name remote hello. So this is how you register yourself to the white pages. So this is the key that we have in order to access this object. So here we are doing the binding. And now generating the stubs and the skeletons. Well, all you have to do is just run the RMIC my remote implementation in order to produce the stub and the skeleton. Now, the skeleton, of course, will be taking place on the server side, but the stub, of course, must be running, must be present on the client side. So somebody will have to take this file, this class file, and put it into the JVM working on the client side. That's a lot of work. A lot of things can go wrong here. Step 4, running the RMI registry, making sure that this is running, and then eventually you run at the final step the remote implementation. That's a lot of steps, So here we have the complete code. So everything is located in the RMI package. So public interface my remote, extending of course the remote interface. Here we have the method that is available for remote invocation that of course will throw the remote exception. The remote service, which implements the above mentioned interface. So it must extend the unicast remote object and of course implement my remote. It actually has the implementation of say hello. It has a no argument constructor throwing a remote exception. And of course in the main method, it creates the object of this class and then makes sure that it is binded to the name that are running or rather present on this machine on the server and put the stub file to the machine that we want to enable to call this method. So the stub will go to the client and the skeleton will remain on the server side. That's a lot of steps, So how does the client get the stub object? So an example of how to actually use this system in the old days. So on the client side, my remote service, my remote using the RMI protocol in order to communicate, not HTTP. So the IP of the remote machine and the name that we have used in order to bind that object to the registry. So we had used the remote hello name. So here we have the full identifier, not exactly a URL, but it is close to that. The client has to get the stub object since that's the thing that the client will call methods on. And that's where the RMI registry comes in. The client does a lookup, like going to the white pages of a phone book, and essentially says, here's a name, and I would like the stub that goes with that name. So as soon as you execute this method, the remote side is supposed to send you the stub. So here we have the steps. The client object uses lookup, the one that we saw right here, uses lookup. The RMI registry on the server side receives the request. The stub object is sent to the client, and then the client can use the stub in order to make an invocation. The RMI registry returns the stub, and of course the client can use the method on the stub as if it was the real service. And here you can see it. The client first uses lookup to retrieve the stub, and then it uses the regular method invocation technique in order to actually execute say hello as if the object service was an object, basically, as if the stub is not a stub and just an object, a regular object on our current heap. But in reality, the moment that you execute say hello, basically it is the stub that receives the arguments, uses the socket connection, communicates with the server, gets the output, and returns it to the variable s. There are a lot of things going on in this very simple sentence, in this very simple statement. So this is how things were used to be done 20 years ago. Now here, can you see my screen?
Yes.
So here is an example of how things are done nowadays in Java. And let me repeat that our course is not about RMI or RPC, so I'm only just providing it to you as general knowledge so that you can see the difference between 20 years ago and now. Certain things have changed, certain things have not. Now the idea is still the same. We simply want say hello method. And what are the steps? Step one, define the remote interface. Now this part is common. So here we have the RMI remote and remote exception that we need to use. So public interface hello. So this interface still has the same job, the same responsibility, which is to declare the methods that will be available for remote invocation. You can have 1, 2, 10, 100, 1 billion methods, as many as you want, available for remote invocation, as much as your computational resources allow you to. Public interface hello, of course, it must extend the remote interface. And whatever methods you have in there, they must all throw a remote exception for the same reasons that we mentioned previously. Remote method invocations can fail in many additional ways compared to local method invocations, such as network-related communication problems, server problems, and so on. And that is why remote methods will report such failures by throwing the remote exception. Okay. That's fine. We can create an interface containing the remote methods. Implementing the server. Now, things are getting a bit more interesting. Now, the server class in this context is a class which has a main method that creates an instance of the remote object implementation, exports the remote object. What does it mean to export? From the RMI package. Public class server implements the hello, so it implements the remote interface that we have declared previously. Of course, it will have to include a no argument constructor, but as we all know, it is not necessary to write it because Java will provide it on its own anyhow. So you must definitely provide the implementation for the remote method. So this is for us to write. And what does the main method do? Now, this is where it gets interesting, because previously, this class was supposed to extend unicast remote object, but that was a disadvantage because that meant that that class could not extend anything else. So in the newer versions of Java, it creates an instance of the server, and it creates a stub by simply calling a static method of the class unicast remote object. So they have changed the system a bit, as you can see, in order not to waste the extension quota of the server class. So it can still extend other classes if it needs to. So unicast remote object, static method, export object. I have given it the reference to this remote implementation. And it returns a stub. Okay, so it has returned the stub. Fine. What am I supposed to do with this? I retrieve the local registry using another static method, locate registry.get registry, and I bind it. I give the stub to the registry, and I make sure that it's bound to the word, to the name hello. And then the server is ready. It is ready to accept method invocation requests. So what happened to calling RMIC to produce a stub and a skeleton? No, it's not necessary. Not necessary anymore. The implementation class server implements the remote interface hello. It provides an implementation for the remote method say hello. And the method say hello does not need to declare that it throws any exception because the method implementation itself does not throw remote exception, nor does it throw any other checked exceptions. Okay. So what about the client side? Because this is done. This is all we have to do on the server side.
Sir, excuse me, before the client
Yes.
side. In the server class, we created an instance of a stub, and we exported it.
No,
isn't that
no,
the
no, no.
opposite?
The stub was exported. The stub was exported right here. It is right here. We are still on the server here. We are still on the server. Basically, what we did was we packaged the server object into a stub.
Yeah, wasn't it the other way around, having the skeleton on the server side and the stub on the client side?
That is true. But the reason that we have packaged it and we have placed it in the registry is so that the client will be able to retrieve it. So the client will connect to the server and tell him, hey guys, where is my stub? And so the stub here is ready. It is ready to be sent to the client.
So instead of retrieving the stub from the registry, it retrieves it from the server.
So the server has created the stub by simply packaging the object, the server object. It placed it into the registry of the server, and it gave it a name. The name of the stub is hello, and then it is ready. And so the client, assuming that the client knows the name, so the name is hello, which is the bare minimum that we can expect from the client to know the name of the class that it wants to interact with. So if he knows the name hello, the moment that it will ask for the stub, the server will be ready to send him this object. It will give it the object and it will say, here you go, the object that contains the names of all the methods that are available to you.
Okay, okay.
So let's look at the client. What does the client do exactly? Now, the client is very simple. So the client first asks the host for the registry. So what is the host? The host is basically just the IP address of the host plus the RMI protocol. So we are giving it the IP address. We are asking the server, the host, to send us the registry. Okay. And from that registry object here on the client, we are basically retrieving the stub representing the class hello, because the host might contain the stubs for several objects. So we are asking specifically because there are several things that can go wrong. For example, this name might not correspond to a stub. I mean, the simplest of errors. Then, once we have received the stub, we are ready to execute the methods in it. So we are executing the method say hello, assuming that it has such a method. And then we simply get the response and we print it on the screen of the client. As you can see, there is no need to execute a registry, execute RMIC, produce a skeleton and a stub, and so on. Everything is transparent. So there has been quite a lot of advancement in the last 20 years when it comes to RMI. As we have seen it 20 years ago, things were very, very impractical. Very impractical. If you made the slightest of mistakes by simply confusing step 4 and step 5 or anything, everything would break apart. Those days it was difficult. Those were the challenging days for enterprise software developers, to say the least. So nowadays it is much simpler. So here it shows us how you compile the files. So javac, etc., destination directory. So you simply, of course, have to execute you have to run the RMI registry, which usually runs on the systems, on enterprise systems, with a certain port number, of course. By default, it runs on the port 1099, but of course you can use any port. On Windows system, it is usually 2001. So that's it, basically, the whole idea. Anyway, our job, anyhow, is not to study RMI or RPC. So this was just in order to give you an idea of what is happening in the RMI world, in order to show you that it is not really that challenging. It is just a question of letting the system know which methods are available for remote invocation and registering them to the system with a certain name. And it is the client that will access them using that name and then manipulate them as if they were locally available. That's pretty much the whole idea. Those who are interested can look up online resources for additional information. Now, class, We will take a break for 5 minutes, and then we will continue with the actual proxy design pattern. See you in 5 minutes.